Hi all, today I'm going to go through 14L, which is the tangent function. By the end of the lesson, what you want to be able to do is to know the properties of the tangent graph, be able to sketch a tangent graph, including finding the equations of the asymptotes, and then to solve trigonometric equations involving the tangent function. So the tangent graph isn't quite different to the rest of the other circular functions that we've learned, both sine and cosine. We're going to go about it in the same way by looking at our x and our y values. So if I were to have our tan graph, which is going to be of the form y equals tan x, if these are my x values, this is going to be my y values. So let's go through. I'm going to go from negative pi up by pi on 4. To fill this out, what I'm going to do is refer to the unit circle. So here's the unit circle, and I'm going to start off at x is equal to 0. So when x is equal to 0, if you think about this coordinate, x is 1 and y is 0. So that means that cos of 0 is 1 and sine of 0 is 1. If you remember our tangent function, so tan of 0 will be equal to sine of 0 over cos of 0. Sine of 0 is 0, cos of 0 is 1, and 0 divided by 1 is 0. So that's how we get that value of 0. Now we've explored all of this through our exact values table, so what I'm now going to do is just use the exact values to fill out the rest. Remembering also that tan is positive in our first and third quadrants, and it's negative in our second and fourth. So if we were to look at our next value, which is tan pi on 4, tan pi on 4 exists here. It's the first quadrant, so we know it's going to be positive, and if you think of your exact values table, tan of pi on 4 is equal to 1. Tan of 3 pi on 4, using our symmetry properties, is the same as writing tan of pi minus pi on 4. Tan minus pi on 4, pi minus pi on 4, is in quadrant 2, and that is going to be equal to tan of pi on 4, and because it's in quadrant 2, it is negative. So that is simply going to be negative 1. Tan of pi is over here, and that is negative 1 and 0, and we'll get the same scenario as 0 divided by negative 1, which will be 0. If we think about our negative values now, negative means we are travelling in the opposite direction of our unit circle, so negative pi on 4 is going to be over here. Since tan is negative in the fourth quadrant, that is going to give me negative 1. And negative 3 pi on 4 is in my third quadrant, which is positive, so that will be positive 1. Negative pi is once again over here, so that is going to be 0. So our final values to look at are when tan is tan of negative pi on 2 and tan of positive pi on 2. That's when x is 0, y is 1, and when x is 0 and y is negative 1. So let's explore that. Tan of pi on 2 will be equal to sine of pi on 2 over cos of pi on 2. Sine of pi on 2 is 1 and cos of pi on 2 is 0. What is 1 divided by 0? Well, if you remember, you can never ever divide by 0, so this is simply undefined. This is how we get an asymptote. So if we were to draw this in, we would have an asymptote, and the equation of that asymptote would be x is equal to pi on 2. So over here, we'll just write undefined. And the exact same scenario will happen for negative pi on 2. So our tan graph gives us two asymptotes, or an asymptote every cycle that we have. So after putting all of those values together, this is our tan graph. As you can see, when x is 0, y is 0 at this point over here, and we have an asymptote at pi on 2 and negative pi on 2. And so what happens is that this just constantly repeats cycle after cycle. So the asymptotes are negative pi on 2, pi on 2, 3 pi on 2, 5 pi on 2, and so on, because on our unit circle, whenever we are along our y-axis, it will always be undefined because we can never divide by 0. As you can see, the graph repeats itself every pi units. So between pi on 2 and pi, that is 1 pi. The reason that it does that is if you think about it, here is one value of tan, say that's theta, and then using our symmetry properties, we are going to get the exact same value, exactly 1 pi later on. In the same way, that's negative, and it takes 1 pi cycles to get the exact same value on the other side. So that's why you'll notice that the cycle repeats every pi units, and so therefore the period of tan is pi. The range of tan is r, so there is no maximum value. In fact, it just continues up until positive infinity and begins from negative infinity. The asymptotes have an equation, in this case, of x equaling plus minus pi on 2. So that's this asymptote here and this asymptote here. And then it just repeats every cycle on after that. So pi on 2 plus pi is 3 pi on 2, so on and so on. And the x-axis intercepts occur at x equals k pi. So tan is 0 along the x-axis over here. So that's at 0, pi, 2 pi, 3 pi, and so on. And so that's when all of our x-intercepts are going to happen. So those are general properties for the graph of y equals tan x. Now what we can do is derive general properties for the graph of y equals tan of nx. So if we have transformation for our dilation. Since the period of the function is pi, that means if I have this dilation factor over here, it just becomes pi divided by n. The range of the function is still r, there will never be a maximum or a minimum. The asymptotes are now at pi on 2, n. So you need to factor in this dilation factor over here, and then every period to the left and the right of these. So you need to add or subtract whatever the period is to get to the next one or the one before it. For the general equation for these asymptotes, we have this formula over here, which can be quite useful for you to just substitute your numbers in and find out what the equations are. This automatically pluses and minuses the period for you so that you can find where the next intercept is. K in this case is an integer, and what that K is, it means it's the cycle. So for cycle 0, we will have K as 0, and that will give us our negative pi on 2 and positive pi on 2. Then when we have K is 1, that will give me the next cycle, and so on and so on. And so K can take the values of anything, 0, 1, 2, 3, but also if we want to go backwards, K can also be negative 1, negative 2, negative 3, and so on and so on. The x-axis intercepts will occur for x equals k pi divided by n. So this time we're taking into account n, which is our dilation factor, and k gives us the next cycle. So now what we're going to do is apply all of this into an example. So what we want to do is sketch the graph of y equals tan 3x. The first thing that we want to be able to do is to find the period. So we know that the period of tan is equal to pi n. So we know that in this case n is equal to 3, so our period is going to be pi divided by 3. That means our asymptotes are going to have the equation x equals plus minus pi to n. In this case n is 3, so we'll have plus minus pi 2 times 3, and 2 times 3 is 6, so it'll be pi on 6. Our x-intercepts will occur at x equals k pi on n. Because n is 3, that will be at k pi on 3. What I want to do is sketch one cycle before and one cycle after. For our first cycle, so that means k is equal to 0, what we will have is x is equal to 0. That's going to be my intercept. When k is equal to 1, x will equal to pi on 3. And if I want to go one cycle beforehand, when k is equal to negative 1, x will equal to negative pi on 3. And we now have enough information to be able to sketch our tan graph. So the first thing I like to start off with is placing my asymptotes. I have asymptotes at x is equal to pi on 6 and asymptotes that are equal to negative pi on 6. So that's the first thing I'm going to place. If this here is x is equal to pi on 6, draw it with a dotted line. And writing in their equations. So that's x is equal to pi on 6, and that's x is equal to negative pi on 6. The next thing I want to do is put in my x-intercepts, so it's going to intercept at 0. It's also going to intercept at pi on 3, and also at negative pi on 3. What I'm going to sketch this between is those values, so negative pi on 3, and pi on 3. Okay, so we now have everything that we need to sketch, and we know what the shape of tan looks like, and so you just need to go ahead and put that in. It somewhat resembles a cubic. Remember that it needs to approach the asymptote, so don't ever come off of it, and it has an inflection point as well in the middle. In the same way, it's going to repeat for the next cycle. However, since we're stopping at pi on 3, it's not going to continue from there. What's going to happen is the rest of the cycle is going to appear beforehand, and so that's what it will look like there, between negative pi on 3 and pi on 3. And there is our fully sketched tan graph. Don't forget to label your axes as well, like I keep forgetting to do. So there's x and there's y. And this is the graph of y equals tan 3x between negative pi on 3 and pi on 3. I hope that all makes sense for sketching. What you need to do is really just practice your tan graphs over and over again. Okay, the next example in your student notes is to be able to solve for trigonometric equations. This shouldn't be too different. We've already explored this in class, but let's go over a couple of equations just to ensure that you understand how to do it. So what we're doing is we're solving between negative pi and pi. What we have is tan x is equal to negative 1. That's for part A. So we want to do the same thing that we usually do. Our first thing is find our reference angle. Now we know that tan inverse of 1 is going to give me pi on 4. Or you can think of as tan pi on 4 gives me 1, so you need to ignore that negative. The second thing is we need to think about, okay, where is tan negative? Well, that occurs in quadrants 2 and 4, and we know that quadrant 2 is pi minus theta, and quadrant 4 is 2 pi minus theta. Then we need to substitute in our theta value, so that'll be pi minus pi on 4, and 2 pi minus pi on 4. Work that out. So this is what x is equal to. That'll be 3 pi on 4 and 7 pi on 4. 7 pi on 4 is not within my domain since I want to stop at pi, but I do need one previous value before that. So to reach the previous value for tan, I know that it occurs at a period of pi, so I can subtract pi from one of my values to receive the one before it. So if I subtract pi from this value over here, that'll give me the value beforehand, which will be negative pi on 4. And so my answer for this, x will be negative pi on 4 and 3 pi on 4. For part B, because we have a 2x, the first thing we need to do is let theta equal 2x, and so we don't have to deal with it. And then we can find the reference angle of theta. So the reference angle is going to be pi on 3. The second thing is quadrant 1 and 3 is where tan is positive. For step 3, all we want to do is apply this. So in quadrant 1 it's just theta, and quadrant 3 is pi plus theta. So theta is pi on 3, and then we'll have pi plus pi on 3. That's pi on 3. Pi plus pi on 3 is going to be 4 pi on 3. What I also want to do to grab some of the values from before it, because I need my domain to be between negative pi and pi, is to subtract pi. So remembering that our cycles occur every pi, so if I just subtract pi from there, pi on 3 minus pi is going to be negative 2 pi on 3. And because I'm going for 2 cycles, because there is a 2 in front of the x, I need to do that one more time as well. So if I subtract pi from there, that'll be negative 5 pi on 3. Okay, so that's what theta equals to, but I'm not looking for theta. What I'm looking for is 2x. So we can substitute 2x back in, and to get rid of that 2, all I need to do is divide everything by 2. So divide 2 with all of my values, and what I'll get is negative 5 pi on 6, that'll be negative pi on 3, pi on 6, and 4 pi on 6, or we can also write that as 2 pi on 3. And so that will be what all of my x values equal to. Check that they are all within your domain, and it is between negative pi and pi. If we need any more values, we can also add or subtract pi to go backwards or forwards. For part C, what I'd like you to do now is to give it a shot, and then we'll go through it together. Okay, so the first thing I want to do is get rid of anything that is around tan. So I can get rid of that 2 by dividing it to both sides, and 0 divided by 2 is simply 0. Then what I want to do is let theta equal 3x, because we don't want to deal with 3x, but in my mind what I do know is I'm going to go for 3 cycles. So I want to go backwards and forwards 3 times. So for 2, 0 doesn't occur in a quadrant, rather it occurs on the x-axis. So that's what you need to think of for 2, and that will allow you for part 3 to know when it occurs on the x-axis. Now we've got 0, pi, and negative pi. That's within our current domain, but if you remember, because there's a 3x, we know we need to go for 3 cycles. So let's continue doing that. That'll be 2 pi, 3 pi forwards, and if we were to go backwards, that will be negative 2 pi and negative 3 pi. Okay, so that's what theta equals to, but we don't want theta, we want x, so 3x is equal to all of those values. So to get rid of that 3, all we want to do is divide everything by 3. So that's what I'm going to do. I'm going to go ahead and divide everything by 3 over here. So negative 3 divided by 3 is just negative pi, and then that will give me negative 2 pi on 3, negative pi on 3, 0 just stays, that will be pi on 3, 2 pi on 3, and pi. And as you can see, those are all of your values that is required. I know it's a little bit squishy and messy, but hopefully that all makes sense. And that's all you need to know for your tan graph. So let's really quickly revisit the learning intentions and make sure we've learned everything we need to. We now know the properties of the tangent graph, so most especially you need to know about your x-intercepts, you need to know about your asymptotes, and you also need to know about your period. If you can find these three, you will not have an issue in terms of sketching it, which leads us to the second point. You need to be able to sketch the tangent graph, including finding the equations for the asymptotes. Don't forget to label them as x equals whatever they are, and so that'll be pi on 2n plus minus. And then finally, we want to be able to solve trigonometric equations, and that's just exactly the same with our step 1 about finding the reference angle, step 2 finding which quadrant, step 3 using our symmetry properties, and then step 4 actually working it out. And that's it. Hopefully that will make sense. Please practice exercise 14L, all of questions, so you can get your head around it.